process called photobiomodulation to change the condition of damaged tissue by stimulating cellular metabolism, thereby accelerating the healing process. A large convex treatment head can be used to compress superficial tissues, displacing excess fluid and enhancing laser penetration to deep structures. As light pours into the tissue, photons will be scattered, reflected, and absorbed. Lasers operating in the near-infrared spectrum from 650 to 1300 nanometers can penetrate to deep tissue structures. Light that penetrates into the tissue can be absorbed by melanin, hemoglobin, oxyhemoglobin, and water. Energy from these absorption events will be dissipated as heat, generating a soothing warmth in the tissue. The primary target for photobiomodulation is the cytochrome C complex, which is found in the inner membrane of the mitochondria. Cytochrome C is a vital component of the electron transport chain that drives cellular metabolism. As light is absorbed, cytochrome C is stimulated, leading to increased production of ATP, the molecule that facilitates energy transfer within the cell. In addition to ATP, laser stimulation also produces free nitric oxide and reactive oxygen species. Nitric oxide is a powerful vasodilator and an important cellular signaling molecule involved in many physiological processes. Reactive oxygen species have been shown to affect many important physiological signaling pathways, including the inflammatory response. In concert, the production of these signaling molecules has been shown to induce growth factor production, to increase cell proliferation and motility, and to promote extracellular matrix deposition and pro-survival pathways. Outside the cell, nitric oxide signaling drives vasodilation, which improves microcirculation in the damaged tissue, delivering oxygen, vital sugars, proteins, and salts while removing wastes. These mechanisms of action have been proved by over 40 years of laboratory experiments using lasers of minimal power. The recent development of higher power Class 4 systems affords the clinician the ability to efficiently deliver adequate doses of light deep into the tissue to reduce pain, reduce inflammation, and accelerate healing.